this little live stream here, and it's going to be doing some PLC development. PLCs are a thing which I can hear my fucking phone running right now. PLCs are what actually controls things like automation. You probably heard of Rockville Automation, or probably or is it Rockville Automation? Shoot, I kind of messed that up. But Allen Bradley is made by the company. What was that company called? I just lost the title. Whatever. But yeah, PLC programming, it's kind of fun. I mean, I'm kind of new to it, okay? So this is kind of new. I mean, I just completed the complete programming course. Instructed by Robert Simons, is what he's called. So it's like a certificate of completion for completing on Udemy. So if you ever do a course on Udemy, you just get like a little certificate you can hang on your wall. Almost like these certificates. I mean, this was for being a Bachelor of Science Computer Information Systems. This is for being the web administrator for IEEE Columbus. And then this was actually a competition with IEEE. So, yeah. But what we're going to be doing is we're going to be playing a game called Automation. And Automation is a PLC programming game. And honestly, it's got its differences from the real world. At least from what I've messed with so far. There's some things you kind of have to think outside the box on, but I mean, it might make you stronger in your development. One thing I don't like in the game is that you can't really do object-oriented programming, which is where we program based off of an object instead of the whole code as a whole. Object-oriented programming will help make things run faster, and also it helps with kind of compressing and organizing your code. So that is not available. However, like if you were doing RS Logic's 500 or 5000, it's a lot of object orientation available in that. Yeah, so let me first show you this game on Steam, because it's available on Steam. This is the game. Automation. It's only $14, I believe. Where is it? Yeah, $14.99 for the price. And I guess it's only available on Windows. But if you're looking to learn this stuff, the price is worth it, okay? Then these are actually some levels that you'll face off against. I mean, be grateful it's not this complex in the beginning. But if you don't know what you're doing, it'll get complex. So, yeah. So let's dive into the game, shall we? Oh, gosh darn it! I did it again. I always forget this part. I need to change my darn camera. Let me give you the screen here. So back to what I was talking about. The game is called Automation. It's available on Steam. It's $14.99, and generally it's ladder logic programming. And I suggest it only for those that know ladder logic. But even if you know ladder logic, you're gonna have to think outside the box, because this is a different type of ladder logic. I don't know if this is how Siemens operates or what, because the ladder logic I've messed with is really different from this. So let's get the game open. So generally when you start the game, you're going to see like a little window that pops up saying automation. We're already past that screen. Then you have this screen here, which is just you got a little analog meter here. I don't know why. I guess the way they have it coded it so that if you're on one side, then the gauge goes down, other side the gauge goes up. If you're not on the image at all. Yeah. The options button here is just deciding you want to have your tutorial arrows on or off, tooltips on or off. Without, I guess that's just doing something else. Sound, control the volume of different things. Save games. I need that. But yeah. Basics is actually a set of videos, so I guess they have some instructional videos, and actually I had to watch them for a second because there was I was trying to figure out why was my timer keep resetting in this one stage, and I found out it's because I was putting it in there backwards. I figured it was just the level, but apparently I was wrong. But I kind of got through most of the game. This stuff is where it starts getting really complex from the paint booth on, because it's more of a bigger factory automation type setting. The box filler, that's going to be filling up a box. The perpetual peppermint, I'm not too sure what that one is. Flipper gripper, I'm guessing this is going to flip something, because I think I saw in the videos. Elevation, I'm not too sure what this is, but it says the first level that was ever made. But I'm going to go down to the basics for you so you can learn, and I'll also show you side by side what I would do if it was a real life scenario compared to if it was compared to this game. So I'll show you this game versus real life code, so you can understand what the prime difference is. So first off, challenge 1, we have to light up this billboard, okay? And to light up the billboard, we have a control panel down here. So it's simple. We push this button, and on will go the lights. All right. I flip the code to run. I press and hold the button. There you go. So we have a working code. Release. It's off. Flip again. Oh, they're cheering again. Thank you. All right. So yeah, that's the simple stuff. That's a really simple code. Let me open up Rockville, not Rockville, RS Logics that I have. It's a free version. You can get this from Rockville Automation. Is it called Rockville? Shoot, am I even saying the right word? That's my question. Hold on. Is it Rockwell? It's Rockwell. I'm confusing my subwoofers with Rockwell. Yeah, so it's Rockwell Automation. Rockwell. So yeah. But we're gonna be, if you go to Rockwell Automation, you can find RS Logix 500. I have it sitting on my desktop in the file RA for Rockville Automation. Or I just keep saying Rockville. Rockwell. You Rockwell. Yeah, so we're gonna be using the RS Logix Micro English. Go get that downloaded if you wish. It is a free software, but if you want to do the emulation, you have to get the links and the classic as well. So, yeah, that's kind of what the automation looks like. Now, I'm gonna go ahead and sample this code for you. We're going to be making this one really simple. It's not that hard. I'll make a new file. We're gonna call it I'll just call it automation. Okay. We'll call it auto. And we're gonna be using a Micrologix 1100 Series B for our controller, but that's just our emulated controller. It's not a real controller that I'm running. Never have I laid my hand on that model yet, so. Alright, so the code that we just did, whoops, didn't want that. Undo that. Shoot, dang it, I need to see that other view. How do I shrink that back down? There we go. So all we need to do for our first line is we're just adding a rung. We're adding, oh, why am I adding that? That's not what I needed. Delete that. I need this. We're open, and we need an output. So first address would be input 0/0. Whoops, I left that on shift. 0/0. And our outputs would be 0/0. So O:0/0. Okay, there's our output. Hit OK, and now we are going to download this to our emulator, which we have to compile this. Compile, code works obviously. It's a simple one. Save. Save. No, oh, did I save that in the right spot? I'll not save that. File. Save as. if I save that in my documents. Go to desktop, RA, and I'm just gonna keep it in projects. Save it. All right. Now I can open up my emulator here. And we'll open up that file in the emulator. Not using the course project. Going to the projects. We're looking for auto. That's it right there. Hit open. I think I'm on station 12 now. Okay, so we have auto 12. Now we can go over to this. Go to comms, system comms. Auto and download. Yes. Yes. Program is incompatible with processor. Okay, I don't know why it'd be incompatible. System comms. Micrologics. Download. Yes. Yes. Okay, there it goes. So sometimes you'll have issues doing your first upload. But I'll hit my run. Okay, we're in a running state. Now if I hit this button here, I'm going to toggle bit. Boom. The output's toggled. So that's the code that we just did in this game. And as you see, it almost looks the same. Not too much the same, but that's a little sample for you. So this is what it would look like in real life if you're using RS Logics. Now, RS Logics 5000, I know that the addressing is a little different. It's not just saying I or O. You kind of have to go find your addresses because the 5000 series, they're a little different. But there's our first one. First ladder made. We'll go ahead and exit this level. Let's go to the Bigfoot tracker. Alright, so first off, we're going to have to add a little either or statement. So these branches here, they're going to make it to be where if one is right or the other is right. So, or if both are right. So if one or the other is correct, then it'll continue to the process. So in this effect, if a sensor picks up anything, then the camera gets active. But what about all this dead space? I mean, seriously, it should just be like whoever put these sensors up kind of should have had them pointing in a little more to where there's no dead space. So I mean, the camera is looking dead in the middle. It's like straight in the middle. So that's just a little thing for the developers. Kind of fix that probably. But let's look at the actual real life code. So in real life, there it is. Okay, so real life, the code would look more like this. We're gonna select that, put you here, and we make another branch here. We're gonna leave the output as 0, 0, but we're gonna add another input here. So I 0/1. Okay. Is that something in the game, or am I actually hearing a fly flying around my frickin' microphone? So yeah, so this is ready. I'm gonna go ahead and download it. Yes, yes. Okay, so we have a running program now. So our east side sensor, toggle bit. Oh, because I'm still in remote program. Hit run. Yes. Okay, so we have the sensor 1 is working. The sensor went off. The other sensor turned on. Okay? It's the same as the code. The sensor went off. Well, now the other sensor's on. So that's the RS Logics version of this code. So we can exit this one. Quit that one. Okay. The Lighthouse. This one's fun. The Lighthouse is a little different because it's actually using a daylight sensor, but I'm going to show you how this actually works I'm going to show you the main difference. They want you to add 2 more rungs. Honestly, we'd only need to add 1, but it's because of the way the game runs. So we're going to add our sensor, and then we're going to add a relay coil. Now, in real life, I wouldn't do this. So I'm going to be showing you how it really works later on, but no contact, no contact. And then we have our light, and we have our motor. All right, run. Alrighty. Now, let's see what the actual code really looks like. So the real code, we'll shut this off. A real code is going to look a little different. That's kind of where I'm saying, like, this game isn't really 100% accurate. No. So real life, we would have our day sensor. Okay. So daylight sensor. But we're going to set it to be not true. So I'm going to take this address here. I'm going to drag it over here. I'm going to delete this one. So if this is not true, then we have our motor being output 0. And we're going to add a little loop over here. If I can get this to click right. Alright. And in the bottom loop, we're going to put a second one here. And we're going to put output : 0/1. Alright. So this is our code. If the daylight sensor is false, then this runs. If it's true, then this doesn't run. Okay? So it's the same exact code. Okay? It's just completely different because of the way that this game works. Okay? So you got to understand, like, I'm thinking outside the box while I'm playing this game. There is no option for the ending to be like this. I've tried it already and it doesn't work. I have to make these extra rungs, which is really bad for programming. It would really slow down an entire system. A factory would be working really slow right now if I went with the programming that this game goes with. But let me go ahead and download this and we'll sample it for you. Yes. Yes. Set this to run. Yes. Alright. So right now it's nighttime because our sensor is false. If I toggle the bit, both of these go off. So now the light's not working. So it's daylight right now. Let's turn it back to night. Toggle bit. And as you see, the branch turned on both these devices. So both the motor and the light are turned on now because the sensor is off. If I toggle it again because it's daylight, now they're off. So kind of implement that into the game, make it to where we can do this type of programming, because I mean, you're kind of leading people, you're kind of doing a false propheting here, I'd say. Alright, so we know how that one runs now. Let's quit that map since we're done with that one. Next one is the conveyor. Now this one, I kind of always like to do one extra step just to show how things work. So this one we have to just make it so that when we push a button, our conveyor will start up. And it's really simple. Push button, poof. And then as long as we don't push the stop button, our conveyor will run. Alright? So really simple, right? Well, how about this? I release the button. It stopped. It should keep running. Why is it not running? It's because we don't have it in a sealed circuit. So that's where we're going to go back to code here. I'm going to add this in here. This is going to seal on my circuit. Put that there. Now, if I have it running, while it's rolling, it'll actually keep running. So I'll hit the start button, and it keeps running now. Awesome. Now here's where I said I like to take it a step further. I'm going to add a rung above this one. If I can get it back to code. We add one rung above. Come on, add me a rung. Okay, probably put it down here. I'll move this one down. There we go. So we have another rung here. We're gonna put. If we push the button, okay, we will have it to be where we're triggering a timer, and the timer will set it for 3 seconds. Now, what's the timer gonna do? It's gonna make it to where if I just tap the button, the conveyor is not gonna run. But if I press and hold the button, then the conveyor will run. So I press and hold it for 3 seconds, then the conveyor starts running. If I hold it for less than that, it won't run. Then we have to hit the done button over here. We're going to say if it's done, then it'll trigger. So I'll stop it. Now I'm going to tap the button here, okay? This is our new code, okay? If I tap it, it's not really triggering the timer. Now if I press and hold, when the timer hits 3, that conveyor is going to start running. 2, 3, poof. Boom, there you go. Now, I'm going to show you why I was lost the first time I was doing this. We're going to look at the settings here for time. So if you see how it goes timer name, then running time, then done time. The running time is how long has the clock actually been running. Now let me show you in the RS Logics what is so different to this code with the timer. Like, even though the timer's not part of this level, I still like to implement it. So we're going to go back offline on this code. No. So we have our push button here. Alright. We're going to add another rung. If I click here, add the rung. And on this rung, we're going to be taking all this stuff, moving it down. First, I'll delete this. I'm going to take you, put you down here because you're my conveyor. So 0, 0 is the conveyor. We're going to go to timer counter. And we're going to do T on. So time on. Now this is where it's different, okay? So timer, first off, we have to declare our timer title. So T4:0. Okay. So timer 4, number 0. Our time base, we have it either set in RS Logic. We set it to seconds, milliseconds, or I'm sorry, seconds, tenths of seconds, and milliseconds. So in RS Logic 5000, you're actually stuck on the 0.001. So, but because what we're sampling here, we're doing with just pure seconds. We don't need the fraction time at all. We're just going to set it to be 3 seconds again. Now, if you notice the accumulation here, 0. This is where I said it was backwards. The accumulation in this game is represented by running time. Meanwhile, in RS Logics, it's actually represented as a 0. Or I'm sorry, represented as accumulation. So the thing I was thinking is done time means, oh, that's when it should be done. Okay, so that's when the time is 0. And I figured running time was like where I put in my actual time. So, but yeah, so we have this done. Now let me show you what's really different in the timer. I mean, you see the EN and the DN. So we have run is represented by EN. Done is represented by a DN. So let's add more code here. We're going to go here and here. We're going to put this back in here. And we also need to make sure our stop button is here. And I'll go ahead and program our stop button first. I:0/1, enter. Okay, so that's our stop button. This is our start. This is our stop. Okay, and this should also be switched around to make it be a normally open. So normally close, normally open. And we have to also add this here, and this has to represent our output 0/0. So if our output is true, then we continue. This has to be represented by our time. Now this is where I said time's different. We have T4:0/DN. Okay, so this is going to say when timer 0 is done. Okay, so timer 4:0, so it's just timer. The main reason why it's called why you have the 4 afterwards is just because that's how it's addressed. But this is our actual timer here. As I run this, you'll actually see that this timer would change. I'm not going to sample that right now, but we're going to have this run. So this is our this is the RS Logic's version. This is the game's version up here. So I'm going to download this. And if one thing that is confusing in Rockwell Automation and stuff, or the RS Logic's applications, is when you're putting the code into the machine, it's referenced as downloading. Now, I would think the other way. I would think if I hit that download button, I'm pulling from the machine to get its code into my computer. And I would think upload would be take the code that I made and put it into the machine. But apparently, it's vice versa. Download actually means upload to the machine. Upload means download to my computer. So it's confusing in the PLC world, but let's see our code in action here. If I tap the button, clock's going to be running, but we need to make sure we're actually in the running state. Yes. So as you see, clock's ticking. Timer hit 3, and the belt's running. And I can hit the toggle bit. The belt will keep running because we have our output signaled here. Now I'm going to hit the stop button, and our belt is off. Now to toggle if I just toggle the bit and release it immediately, as you see, nothing's running. But if I hold it again for 3 seconds, 1, 2, 3, and I release my button, ooh, what happened there? Oh, it's because I still have this button pressed. Toggle the bit. So toggle this. Hold 3 seconds. 1, 2, 3. Toggle bit. Boom. Our belt is now functioning again. Now I'm going to just go ahead and hit my stop button again. So as you see, the real world, it's kind of imagination. You got to imagine where everything's at. We'll go offline again with this. No. Shrink that down, and let's go to the next level, because we just did this in 2 different ways. Quit this level. Parking lot I'm going to skip. Parking lot's annoying. It's just a big headache. Ferris wheel. This one's fun. So the Ferris wheel, the challenge is we have to use memory and math and stuff. So for the Ferris wheel, we also have to create our own little control panel. So I like to control with speed. Okay. And say SPD. Okay. So that's our analog control, and then I also like to add a button, or not a button, a switch, selector switch, just to make it be on or off. Because I prefer my switches rather than my buttons. Just because, I mean, I could press and hold that button all day and then set it to run, but I'd have to have a second button in order to stop the whole system or trigger a sensor. So we'll set this to be called run, and then we're gonna call. Oh, you got 3-state or 2-state. That's pretty cool. So the 2-state, the top one is our stop. The bottom one is our run. Okay? So we want to put this over here, put it on run. We also have to have another rung here, so I'm going to move this down here. The wheel. Now, why do I have to have this other rung? That's because we need to take our speed controller and do some math. So first things first, we take our, do we have to do that? Yeah, math. So we take math. We go over here. We're going to code our math. We're going to select the memory block, which is the wheel speed. Or actually, I'm sorry, we need the speed. Okay. We're going to multiply it by 5. So we're going to multiples of 5. So whatever the speed dial says, that's what our, we're going to take that value, multiply it by 5, and that's how fast our wheel will go. So if it's at a value of 10, it's going to be going 50 miles, or 50 RPMs. I don't know how exactly the thing's supposed to be going. But value 2. So finally, we have to send this to our wheel speed. Hit OK, and OK. So now, if I set this to run, you see our speed is at 0, but as I increase this, our speed goes up, and up, and up, and up, and up. Now you see it's a value of 11 here, it's a value of 55 here. So bring her down, we're going to put it probably around put it at 0, set to run, and we'll bring our speed up to 2, which is actually going to be a value of 10. So you see our Ferris wheel starts running, give her some more speed. It's pretty awesome. Now if I flip my switch, the system will just stop. But if I click run again, it'll start running. And I can increase the speed all I want. We'll get it all the way up to 55 just to watch the Ferris wheel go out of control. Yeah. And I'm sure an actual theme ride, we probably use different math. Probably lower that number, probably to 2.5. But right now we're just playing around here. So I mean, in real life, I wouldn't set the number to be 5. So I wouldn't take it to that speed control. I'd say put that speed controller, put it at probably 2.5, because a natural speed probably might be at the. I'd say that. So if I lower this down to where the motor speed is at 20. Probably 12. That's where it seems going at. So, leave it there. Now let's look at the RS Logics edition of this code. We're gonna do, go ahead and delete this rung. Delete this rung, just to start over. So this rung, what we're gonna do is we're gonna first implement our math, and that's where it kind of be a little tricky in a way. Let's see. Go over here. Compare, compute math. Okay. So, we have to multiply. So we're doing some multiplication here. Source A is going to be... We have to have an analog input. I don't really have an analog input. I don't really know how to sample an analog input. Because I haven't really messed with analog inputs yet. It's something I'm hoping to learn here soon. But we'll do this by hand just to sample it. Yeah, I don't have an analog input and analog output, so I can't really sample this for you truly. Put output. Kind of helps if I had some fun with it. If that class I took actually showed more analog stuff, they didn't really show too much analog. So that's something I'll have to learn later on. It's always worth learning. Yep. Alright, the water tank. Now this was actually kind of one of the levels that I had to do in this class. Okay, so this class, they actually had one of the challenges was you have to make the water tank actually stay leveled. Okay, but the way it worked is there was 4 sensors called floats. So you had 2 low sensors and 2 high sensors. So you had a low sensor and a low, a high and a high. So you had to set it so that the water was always staying in between these two. But say the high sensor failed, then the high sensor got triggered, then you had to shut. Then I had it set to where it would shut down the whole system and sound an alarm. If the low sensor was triggered, it was supposed to trigger pump 1, and if the low sensor gets triggered, well, falsified, the low sensors were always high, but if they became false, that's when the motor would turn on. So if the low sensor became low, the pump 1 was supposed to start filling it up. And it was supposed to alternate between 2 pumps every time, but say pump 1 was filling up. But then, say pump 1 was assigned, but we got down to the low sensor. What would happen is the low sensor would say, hey, pump 1's obviously not working. I'm going to flip you over to pump 2. Okay, so pump 2 is going to try running. Well, if that low sensor doesn't get triggered after so long, then an alarm sounds saying, hey, both these motors are having a fault right now, so I need you to do something else about it. I'm going to just sound an alarm and say, hey, get over here, check this sensor, check out these motors. Neither one's pumping to my tank, and I'm going empty. So as you see, the sensor is a analog sensor. It's sending a signal right now of 3.06, so it's about filled up to here. This is something that kind of bugged me when I was playing the game. It kind of would help if you guys did like a different, like some color here to signal where the water level actually is. Kind of give more of a visual cue for learning with. Because I'll show you here in a second. When this is actually running, you don't see water going up or down. And with it being a value of 3, that's actually 30%. So the tank is about 30% full right now. That's all I know. And that's just from reading that one gauge. For those that don't know how to read gauges, it would help if you actually had it to where you can actually see a water line and kind of get a better understanding. But I mean, probably they didn't do that on purpose. But I mean, hey, I can see right through this thing right now. So why not make it so I can see a little water line? Make it a little more foggier in here or something to signal this is where the water is. But let's hop to the code. Let me see this. It's like a little planet. It's its own little planet. Nice. Okay. So here's the challenge. First off, we need to, if our sensor, we have to kind of declare 2 things here. First off, we need to declare, is our sensor below a certain value? Okay. So we're going to do a comparison, and we're going to see, is our sensor, the tank level, is it less than or equal to a value of 9? Okay. Now, why are we doing this? It's because the way we have to run the logic. Oh my god, I'm getting air. Now for the next step here, we have to declare the motor to be running if it's down to a certain, if the tank gets down to a certain level. So that's where I'm going to add another compare block, and this compare block is going to say, hey sensor, are you less than or equal to a value of 2? How about that? So we're going to fill between 2 and 8. So we're going to try to make sure the tank always stays filled at least at 20% up to 90%, okay? Because we don't want it overflowing. Granted, I could set it to where it stays up to 10. Now, an amateur mistake that people would make is they would actually set it to where it's always at 10. Whenever it falls like one little niche below 10, it'll automatically fill again. And what you get is a motor that's just constantly tick, 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 tick. That's what you'll get out of that. So that's where you kind of have to set it to where we have a point where we want it to trigger at, and then we have a point where we want to stop it at, okay? So we want it to stay in this area, okay? As long as it's in this area, it's fine. If it's going down, that's fine, okay? We need to set it so that when it actually hits this bottom trigger, then we trigger our motor so that our motor isn't just constantly ticking and letting in just one little drop at a time, and we don't want to be destroying our tank. So what we need to do here is if this is less than or equal to 3, and we're going to add a block down here, and this block is going to say if our value is true, because it's less than 8, and we have our pump running. So our pump motor would be running. So, and pump motor running. So if this is true, hold on. Is this supposed to be, yeah, if it's less than or equal to, okay. So if it's less than or equal to this, equal to 9, and the pump motor is running, it'll keep running. But if it is less than or equal to 3, it'll run, okay? So let's watch this in action. I'm going to select this so we can see our value. It's going to fill up until it's at 9. Okay, now it's going to start going down. When it gets down to 2, it's going to fill up again, okay? 3, 2, and trigger. See? So it's what's going on is it's trying to fill itself. Now, granted, that top sensor is probably always going to always be active because it's being triggered. And yeah, it knows that it's less than, but we want to set that top level to be our kill switch. So if that top level is becomes true, then it would kill the system. That's the point in it. That's why we had to put that first rather than being down here. I mean, I could have put it down here and set it to be if it's more than. So, I mean, honestly, I don't need this extra rung. If I want to, what I can do is I can just have this sitting in here where C1 is and set it the opposite of how I have it. So if it's yeah, if it's less than or equal to 8, then do it. So I could just take this and drag it right here. It's not really needed. This line isn't really needed. In fact, let's just do that. Let me put you up here. I'm going to take you, put you down here. Now I'll delete this wrong. Okay, run. You'll see it's going to go down, 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 down. Trigger the motor. You see it'll fill until it's back to 8 again. Once it gets back to 8 again, it's going to drop itself. It's going to stop again. See? So we put all that in one single line. So my code at first was kind of not too compressed. Now I have it compressed. And honestly, the more I've noticed, last time I did this level, I did have it looking a little different. It did kind of look sloppy. So the more I do this, the more I'm kind of waking up and seeing, oh, why didn't I try it like this that time? So that's the benefit to doing this stuff over and over. Make sure you keep, if you do something like this, like be it a coding game or something else, just do it over and over. So this level we would declare done. I'm not gonna sample this level on the other thing. So the marble sorter. This one's kind of fun. I mean, this is great for amateurs. I mean, one thing I'd like to do is probably make this level in real life, just to sample with real life for a STEM class or something, the automation process. And actually show them what a real sensor looks like and what different things look like. So I'd probably try getting sponsorship through IEEE or something for that project. But so first thing we have to do, we have to scan our balls. The balls that are going to be coming out of here for you dirty-minded folks. First, we're going to do a comparator here. So we're going to do a compare block. So first, if our scan is equal to a 1, that's going to mean that we have a red ball and it's going to go to the left. So what we have to do is we have to take our motor here. We're going to set it to be on the left. Our swing gate goes to the left so that the red balls go to the left. We're going to add another rung, and this rung is going to do the same exact layout, except this one is going to be the opposite, where if the value is of 2, so if the scan value equals 2, then we're going to go to the right. Okay? And we just hit the button here, and I'll click on the screen so you can see this in action. Should hear a ball coming in any second. There you go, you see that? So what it's doing is the sensor is detecting, is it a yellow ball or a red ball that's coming out right now. And I think this would be really awesome to do in real life, to have a infrared sensor detecting if the ball is yellow or red or black or blue. But the problem is the more colors I have, the more lines I have to create. Otherwise, we could do a simple math equation, determine probably figure out if we had 10 different colors, if we had it in a range, so if the scan comes up between this and this, then it'll do something else. So honestly, for the creators of the level, I think, you know, it would be really interesting is if you actually added way more line, like more machines to it. So make it to where there's probably like more color. So give the option for other colors to where if it's A or B, so if it's 1 or 2, then it goes to the right. If it's 3 or 4, then it goes to the left. Then in the next station, it's going to separate them, saying, okay, are you red or blue, or are you green or black? So are you 1 or are you 2? So there's going to be a total of 3 sets you have to develop on. So 3 different sensor stations, but you're dividing into multiple colors. So that's kind of one idea I have for another level if you guys ever made one or something. So if you're watching. And this video is being recorded on 3 platforms as well. This is being streamed on Twitch, Facebook, and YouTube at this moment. Once Twitch is done, it's gone, but Facebook and YouTube, this stays forever. So there we go. So far we've gone through 31 yellows and 39 reds. So yeah, and that's just going to keep going infinitely. It's like a factory. Let's go to a new level. Quits. Yes. Paint booth, do I want to do that or I want to do the Palletizer? The Palletizer is kind of what I want to do. I don't know. How about the box filler? The box filler is a pretty simple one. I think the box filler is a little easier than the box Palletizer. So the box Palletizer, the goal is you have to load everything on the box, on the pallet, and it's one of those levels I really wish they had some frickin' object-oriented programming. Because the way I would want to run it is I want to run the top area in one script, the bottom area in another script, and then every motor and every sensor in their own script as well. Just because it would make things a lot easier to deal with. Trying to do this game without object orientation is like becoming a headache, but I think there's a lot of PLCs out there that actually don't support object orientation. In fact, I'm glad PLCs exist, because if you knew what they looked like before, you'd be amazed. There was actually walls upon walls of things called relays, okay? And the relay would be, you have 3 inputs, okay? Or you have 1 ground and 2 inputs. And these things would have to be taking, okay, is it high? Okay, so the sensor is coming in high, so I want you to close this coil and let the power go from here out to the machine. So what it would do is it takes the signal from the unit and it triggers a machine. But this would be a closet bigger than a bedroom filled with these things. When now we were able to compress it down to this little tiny thing. So we were able to take what used to take closets and compress them down to these little tiny little circuit boards. So yeah. Let's have fun with this. I was kind of fiddling with this earlier, but then I decided I'm going to head out because I wanted to go swimming at a pool with my mom and my step-niece. And my stepsister. Alright. So this challenge, we have to fill these fill boxes up with ingredients, but we also have to make sure the scale is of a certain size. So first off, I'm gonna just put some code in here just to make the belts run in a way. This is some basic coding logic I've been using. If this is not high and this, then we're gonna add another line here. Whoops, leave that there. And this one is not high, but this motor is running. So that's where I add another rung, and that's where we have to actually put this in its own little code too. So add one below. We got to put this in here. I'm gonna put this up. So if the scale, PSC, the sensor is not high, then this motor will run. Okay, and if this motor is running and this is not high, hold on. No, if this motor is running and this is not high, then we'll run the other motor. So this motor will run. So first one is saying, okay, is the scale full? Like, does the scale have anything on it by detecting here? Scale has nothing on it, so I'm going to roll that one. Now this one, does it, if this has nothing on it, but this sensor is blocked, we're still going to roll this one because this track's now empty, so we can roll a crate out. And if this sensor is active, but this sensor is not, the belt will keep running while this belt stops. So we're going to go ahead and load a box on that now. Yes, we'll run. So you see both of our motors are running right now. Box passed sensor 1, sensor 2. There we go. So our scale is loaded now. Now we have to measure our scale and get it to be the weight we want. So we can go back to code, and we will activate our pump. So we're also going to create memory blocks, being state and value of 0. Well, actually, it'll be a value of 1. Okay. So this has to either be, we're going to have to add an OR statement here, being if the state is, so state 1 is loading, or state 0 is loading. So 0 means we're getting the pallet on. State 1 is pouring goods. State 2 is rolling off. So if the state equals 2, so we'll add a secure here. We're going to put the state, okay, is equal to 2. Okay. And then once we have this sensor triggered, we will when this gets triggered, we reset our state down to 0. So if this sensor is triggered, let's add in line for that. So sensor 3, you're triggered. We're going to do what's called a one-shot, meaning like the code will only happen once, and then it's going to reset until it resets itself. Because as the scanner is scanning, if I had math in here, it'll just keep counting while it's high. The one shot makes it to where, like, once it's triggered and set to high, it'll only run this line once until this trigger gets shut back off, and then it'll reset itself and do it again. So if it's high, we're going to do copy. And we're going to copy the value of 0 to the value of state. Okay? So state will be a value of 0 again, and we can roll our motor. So state's 2, we can roll our motor. And this state, in order for this one to roll, we need this to be a 1. So this one has to have a state of 1. So the infected speed, or in-feed speed, roll 2 would have to be running, but if it has a value of 1. So if the state is equal to a value of 0. Okay? So if the state 0, then we can start feeding. Okay? So we're going to wait till the platform's clear before we actually activate it. Now, to change our state to state 2, we need our scale to be greater than a certain value. So we're going to add another line. So in order to get to state 2, the scale must be equal to so much. So we're going to compare scale weight, okay, is equal to or less than, or I'm sorry, equal to or greater than 125. Okay. So if this is true, then we're going to do a one shot, and we're going to set the state to state of 1. Okay, so that's where we're going to do a math block, and the math block is going to say, okay, I want you to take your state, and I want you to add a value of 1. Okay, so now we're on state 2 because we reached our goal. Now we can activate the belts and start running again. So if the state equals 2, belt runs, and then when this goes dead, then okay. Let's try running that. Math. Why is the math failing? Math. The value of state is 1 plus scale weight is equal to. Okay. So I think it's failing because it's not calculated yet. Or was it that I stayed? This and stop. Okay. Oh, if this goes high, so we're going to add another line where if this sensor goes high, okay, we're going to do a onesie, and we're going to do math again, the same exact math block this is. So math, this math block is going to be the same as state plus 1. So do state. Actually, hold on, I got a better idea. We're going to add the rung here, or the OR state, the OR step, because it's either this happened or this happened. Okay, then we could delete this math here. So if it's one or the other, you can run it. Okay, and math plus 1, and then if the state, hold on, does it? Yeah, it's not going to work because it's scale. Hold on, scale PLC. Okay, the scale's high, so we went to step 2. Step 3 is if the weight is so much. So if we're on step 2, so we need to, or I'm sorry, step 1. So if our state, okay, is a value of 1, okay, then we can pump our goods. So we're going to do just one pump first, and then we'll probably add the other one in another way. So if it's that, then we can pump, okay? And once the goal is met, this gets triggered, we move on to the next state. So run. I think we're kind of overflowing it. Let me see the math here. Where's my state? State should be +1. As soon as that's triggered, it should have run. So scale currently 100 is greater than or equal to. So scale is greater than or equal to 125. So we should have triggered the next state. Okay, I guess we're going to have to add another rung here and make it to where we can call out this. I'll have to erase this rung here. And we'll have to add another piece of math. Same math again. Just because this app doesn't really know how to run things too well. Okay, +1. Okay. So now now we got 2 separate stages. This should be causing it to run. What? Why is it? Let's see here. What am I doing wrong? So I have you loaded. Dispensary 1. State is still 1. Okay, I'm going to add another rung, and this one's going to be for declaring if the state is correct. So on state 1. Okay, cancel. So while this line isn't true, I want this line to be, well, this is not true. Okay. And then we're going to do our one-shot math. So if this comes back not true, and the state is equal to 1, then we can dispense. Okay. Now that this is true, we do our one shot, do our math, change the state. Boom. C1 is true. You're true. Dispenser spool. Why is the math still screwing up? Why do you screw up? Probably two. Oh, because I don't have an output selected. Duh. What the heck? Okay, so output to state. How did I forget that? Yeah, we had to send it somewhere. Okay. Okay. Run. C1 true. Okay, where's the memory block? State's 3. Okay. Now we have to, if state is 0, we have to also have the third belt running. Third belt's actually always going to be running. Third belt will always be running. So we need to add another rung. Belt 3 shall always run. Okay. So we're going to take this one. Just leave that to always run. yeah, look at that. We have a factory running now. How cool is that? We just coded a factory conveyor belt to fill up until it's a certain weight. Okay. You can see our weight right here at the top line here. So it's filling until it's at 125, then it cuts itself off, starts that bottom conveyor belt. Once the box is clear of the middle conveyor belt, and the following sense, once it's clear of the conveyor belt, what's going on? Do I not have scale weight? Oh, what's going on? Why is it not processing? We're at state of 4? Why is it in state of 4? Second state. I'd say our little conveyance system here is running well so far. Now let's try to alter products so that every time it'll switch between pump 1 or pump 2. So we're going to make it to where we can have 2 pumps running. Otherwise I could... Ooh. So it seems we have bugs going on, so if we need to probably put a... Let's do that. We're going to put a sensor for if this goes higher than 2. So if it's at a higher stage. So let's add a red light. Okay, so it's going to be my warning light saying that so bad state, and then we're gonna add a button that would set it to be a value of. Okay, so so middle empty. Okay. Context member but must have a unique label found in outputs. Okay, fine. Trigger stage 2. Because it's full, we just need to get it back to stage 2 so that it knows to unload. Okay, so if it's set to stage 2, then we have to, if we click the stage 2 button, we have to do something else. But we're going to add a rung here, and the rung is going to be our comparator saying, hey, our state is high. So if my state, okay, if my state is greater than 2, I'm sorry, greater than 2, okay, then light turns red, okay? Then we'll add a new line, and this would be, if we push this button, then we're going to copy the state from 2, and we're going to store that. Store in the state, okay? So, click OK. Alright, So now if we push this button, it'll change the state to 2. Alright, so go to run, click button, we're in state 2, back to state 0. State 1. I don't know why it keeps doing that. So I'm guessing it's a false signal coming from the sensor there. So let's stop code for a second here. I want to add something else, and this is going to be how we decide which motor do we want to have running. So we're going to go to selector switch, and the selector is going to be product. Okay, and we have 2 states, so either it's going to be the left motor or the right motor. Red, and we're going to say green, so red or green. I think we're making apples here, or we're packaging apples is what's going on, so we know it's either a red or a green apple. So dispenser 1, we have to copy this state here, so we're going to have to add a line above this one and a line above this one. Okay, so this is going to have to be moved to a new coil. This coil is true, or this coil is true. We'll run step 2. If we have it on that, then it's going to do the red side. If we have it that, then it's going to go to the green side. Alright? So at the moment we're set for the red apples to come out. But if we flip this, it'll switch over to the green apples. Switch my center and see if we get green apples. Yay, look at that. Check that out. Green apples are coming out now. So I'd say we pretty much have a well-working machine here. I didn't see any factor of the achievement. Like it usually would say, like down here, hey, did you achieve it? Uh-oh, that state. Click the button. Just in case we're in the wrong state, so I have it like that. I mean, if it would be higher, if it. Yeah, see how it triggered there? Really questioning what's causing it to do such a count, right? Because it's only on certain boxes. I'm guessing sometimes when it's dropping in the box might shift a little or something. Yeah, see, it started running and it triggers. I'd say our machine is done, other than the fact that we sometimes have a bad state, but that's just saying, hey, the machine kind of tripped for a second. So yeah, you see we have a red light turning on if we ever have that issue happening, so I see a red light saying like we kind of something's jacked up. See, it worked that time. time. Let's see, red light turned on. So I'm just gonna say this level's done. I don't think the game's really telling me what they need. I mean, one thing I'd probably like to do is make it to where every other box is different. Like box one, this box right now is filling up with green, so the next box will be red. Then the next box will be green. Then the next box goes red. Next box green, next box red. So I'm just gonna consider this level's done. See if it actually marked it as done. No, it doesn't. Come on. Oh, whatever. Let's try the flipper gripper, because this seems like it might be a, looks like it's flipping plates or something. Like, it'll be, plate gets loaded on, comes out here, we have, one motor will take it, put it out here, then it turns to the next stage, grab, flip, turn to the next stage, grab, flip, next stage, grab, flip. This looks more like a factory. This will be kind of interesting. So, flipper, gripper, and ripper. Flip the discs so they are blue side up. The flipper assembly is able to move up, down, in, out, close, and also rotate. Okay. Rotate the table using the motor in the center. The sensors will activate when the table is in position. Okay. Place discs on and off table with the stacker. The stacker can move up, down, and rotate. The vacuum pump provides suction to pick up the plate. So, let's see. Where's our... This is where they're coming from. So we have this here. I guess that's supposed to be our vacuum pump. So that's going to say vacuum on or vacuum off. The sensor here is going to say, okay, we have a item in the sensor area. So I'm going to go down. I'm going to collect you, pick you up, rotate, and place you. Meanwhile, while it's selecting this one, let me see. Clockwise or counterclockwise. So lifter, see what. So that's the rotation. The vacuum pump is going to turn on both of those. This is the conveyor line. So I'd say step one, we need to get it to where our conveyor here will run until we have an item in the area. So if this is false, then this motor needs to be running. So this motor will start running whenever it's empty, and once this trigger is high, then this motor will stop. Okay, and then we'll pick it up. We're gonna say if this is high, ooh, we need to actually add another rung because that's gonna be kind of a crazy case. So if this is high, I'm sorry, if it's false, if that's false. So if this is, yeah, so if this statement's true, so the no item in sensor, then we'll run. If it's false, we'll lower the lift. That's the rotation. Here we go. Lift her down. We're going to set it to where it continues going down until lifter fully down. So while lifter is not fully down, lifter is going to keep going down. Okay? And next we go to lifter fully down, and the vacuum will turn on. Okay, so lifter fully down, vacuum on. And then if vacuum on, vacuum is on. Then lifter goes up. And if the lifter is not fully up, same code as the lifter going down. Oops. Lifter goes up. If lifter is not fully up, and it's running, then it'll continue going up. Then we have to rotate the station. So we have to rotate this one way, and then we have to bring it back down. Oh my gosh. So I'd have to call back upon this method again. Be like, okay, how do I call that method again, though? Because there's no way for me to reorder these again. So it's like I'd have to... So we picked it up. We need to rotate it now. So we have items are up. If lifter is fully up. So let me see. Lifter fully up. Then we start rotating. Got to go counterclockwise. So we're going to have to add a state for this one. This one's going to have to be like states. What state are we in? Right now we're in the lifting state, then we're in the flipping state, then we're in this state, then that state, then that state, then that state, blah, 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 blah. Yes, this one's going to be a little more complex. This one's going to be way more complex than I'm making it right now, because the way I'm making it is a straight line. Okay? I'm making it the way the code should be. Okay? But they're making it to where I have to really think outside the box and do states of process, and that's not a simple process to do. So we the belt's running, we picked it up, turned it, dropped it. This is a crazy level. Lifter fully up. Lifter goes counterclockwise. And while the lifter is turning, and it is not fully counterclockwise, then we have to go back to lifter down. So could we add another rung down here and make it to where if lifter's going down, or we can add a clause. So I think we have to add states here. So that's what we're going to do. We're going to make it to where, erase this line. We're going to make it to be where we're in the down state, and if it's in the down state, then lifter down. So oh my gosh, that's why I wish it was object oriented. It's something else. This game really forces you thinking outside the box. So I don't know what's going on with that right now. Let's go back to this first sensor, because this sensor honestly can run on its own. This one we can leave as a as long as this is false, then this belt can run. Belt 1, you can run, but if it's true, then it'll trigger the next state. Okay. We'd have to go up, flip, down, release. Up, flip, down, release. Up, flip, down, release. That's a straight shot. So this we could actually do. We can, actually we have to stretch it back out. So, we'd have to call out a state again. That'd be a multi-state as well, because it has to go back out. Well, no. Push out, lift, flip, down, release, in. Yeah, that's fine. That's fine. Hold on. So is this the in out? Yeah, slider motor. So, okay, table sensor. Okay, so table ready. So we'll add table ready. Then we're gonna say we're gonna have to put that in a little thing here. So table is ready. We're gonna have to add another rung, and this rung says the table's ready. So go out. So arm goes out. And while the arm is going out, fully extended is false. Okay. Then it's fully extended. We go here. Fully extended is true. We're going to close the grips. And while the grips are not fully closed, oops, hold on. Oh, come on. Stretch. There we go. And while the grips are not fully closed, we're going to keep closing. Once it's fully closed, the lift will go up. So actually we gotta select this here first. Fully closed is true. Lift goes up, and the lift will continue going up. While it's not fully up. Okay, and then we're going to do another line, fully up. Then we can turn this. So that's the slider motor, rotator. We'll just rotate clockwise. So rotate clockwise, and we continue rotating until the fully rotated is true. And then once fully rotated, the arm will go down, and we continue going down until the sensor is fully down. And if it's fully down, we open the grip. And we continue opening until fully opened. fully opened yet. Come on, let me get the frickin' stretcher. There you go. Okay, continue opening until fully opened. And finally, when fully opened, once we're fully opened, we gotta add in the ore for that. Okay, fully open, we're gonna retract this in, and we're gonna continue retracting until it's fully retracted. And finally, when it's fully retracted, the table shall cycle. Okay, and the table will cycle and cycle until yeah. We still have to have a state for this, so we have to count every state and keep counting up, and then once it's done, then we can do the next one. Retracted, and table is not ready. Okay. So we have to include states in this step, obviously. We're going to create a memory block for flip station. So flip stage, value of 0. So value of 0 is going to be the motor. This is getting in position. So table ready, we trigger C2. Oh my gosh. Watch how this runs right now. See, it's going to keep running non-stop. It's a hard little nut to solve here. This is kind of tricky. This one's being tricky. It's gonna need stages, obviously. If this was object oriented, I'd probably be way done with this by now. But because I have to think outside the box, because I can't reuse things and stuff, it's something completely different. Let's we'll call this one quits for now. I'll have to get a dry erase board to figure that one out. So far we have 2 of these that I haven't really done because I can't really get them running right. Perpetual peppermint. So I'm guessing this is making peppermints probably. This one I haven't tried. We'll see how this one works. The everlasting gobstopper. No. Alright, get a look under the sheet at the most secret machine of the Candy Factory, the gobstopper machine from Willy Wonka. Spin the wheel, push the pushers, follow the recipe for perpetual peppermint scissors. Recipe steps: red and green out, yellow and blue out, spin spinner, red and blue in, green and yellow in, stop spinner. This one might be a little easier. So first we go extend green and red. So first off, first stage is trying to solve this. I haven't even eaten today, so I think I'm gonna just call it quits for right now, because this is this is quite different from real life. I wonder how this one would work. This is supposed to be a elevation, so it goes here, stops here, sensor's high, it goes up. Once it's fully extended, we go to the next stage. This isn't down all the way, so we're gonna stop this belt. We're gonna fill this one with weight. Yeah, this one looks like it'd be pretty simple, honestly. I mean, it looks like it's just one single box, like it keeps working in a circle, probably. That one looks like it's a circle. We'll do with one thing first. So PSC 1 is not occupied. Then the rolls will be true. Okay. If it's occupied, then actually if it's not active, yeah. And or the what's the limit? Yeah, let's just call it quits for now. I need a break. I think that's just gonna do it for today, or for right now. I'm gonna go take me a break and then go get me something else to, or go get me something to eat, and then probably I'll come back, play something else, because this is kind of crazy. I mean, kind of see how someone tried writing this code, but yeah, it's just a lot of process to go through. Yeah, I think I'll check out for now. We gotta, no, I don't want to save the changes to that. Okay, no, I don't want that. Yeah, I think I'm just done for now. We'll go ahead and close out of this. I don't know when I'm gonna come back and play, but I think I just need to take a break from all this automation stuff, and I need to take me a nap, because I'm just getting tired. So I'm gonna check out. Thanks for watching. I'll see you in the future.